Hello, Merry Christmas Eve. There's only one day left after this one. And what I want to talk about today is indirect searches. For me, this is something which does not get enough attention. It's very attractive to see a direct search for the Higgs boson, for example. You know, we're searching and we find a bump in our data and we add more data and the bump gets bigger and we say, hey, it's 5 sigma, it's a discovery. And everyone gets very excited about that. But that's only one way to search for a new particle or a new kind of physics. The other way to do it is through indirect searches. And the way it happens is the following. We have a prediction for how often a process should happen. And then we go ahead and measure that process. And if it comes out higher or lower than expected, then this must be because there's some kind of new physics happening. So I gave the example a while back about the top quark. We knew the top quark was heavy, and we placed limits on how heavy it was. And the way we did that was by looking at B sub S mixing. Now B sub S mixing is a process that happened a lot quicker than we expected. By measuring how quickly it happened, we could then translate that into a limit on the top mass. And that told us that the mass of the top quark was very high. It must be more than 100 gigaelectron volts. It turned out it was about 175 gigaelectron volts. And we can do the same thing for the Higgs boson. There's a group that put together lots of measurements from all different areas of particle physics into what was called the electroweak fit. And this predicted the mass of the Higgs boson. It said that the most likely mass for the Higgs boson was 90 GeV. It turns out it was a bit higher. It was actually 125 GeV, give or take. But that was only 2 sigma away from where the electroweak fit predicted. And 2 sigma is about a 5% probability, so the chances were 1 in 20 that we'd get those electroweak fit results, given that the Higgs boson mass was 125 GeV, and that's quite a large probability. So everything seemed to work out there. Now, if we'd have had a Higgs boson mass of 600 GeV, things would have been very different then, because we'd have had a big mismatch between the Higgs boson mass and the electroweak fit, and that would have told us that there's new physics in there that's causing this. Now, that isn't the case, so what we need to do now is incorporate the Higgs boson mass into the electroweak fit and use this to constrain other models in the future. Now, the LHC is currently not taking proton collisions, and next year it will be taking some lead collisions, but then it's going to shut down for a period of about 2 years. After that 2 years, it's going to turn on again, we'll have more proton collisions at higher energy, and we'll have upgraded our equipment and our detectors. We need to be looking now at what we want to search for after the upgrade. We need to get those plans in place so that we know how we're going to approach that data set. And one of the ways we can do that is by taking the Higgs boson mass, the rest of the electroweak fit, and taking all the other exclusions we have and working out what the most probable masses are for particles beyond the standard model. And by doing that, we can put together a plan for physics for the next 5 to 10 years. And I think that is what we should be doing as soon as the long shutdown starts. So, even though direct searches are very glamorous, very exciting and get a lot of publicity and attention, don't forget that indirect searches are extremely useful as well. Okay, well, I'll see you tomorrow for the final video. Okay, ciao. I should probably make a confession at this point. I'm not actually a Christian. I'm an atheist. That's not unusual for people from the UK. I was raised an atheist and raised to question the world around me, to look for answers, but also to find the beauty in the world around me and to find beauty in those answers. Now, for me, if I was going to give a meaning to Christmas, I'd say it's a time when we spend time with other people, we show them that we care, and we keep in touch with our family and with our friends. Now, this was particularly important when I was living in the USA as part of my PhD. I was doing research over at SLAC, and an opportunity to come back to Britain didn't present itself very often. So it was around Christmas time that I'd come back and make a special effort to see my family and friends. And since moving to CERN, that's become a bit easier. But still, what I'm looking forward to most this year is seeing all my family and friends again, because I do miss them. Make sure you make time and space for your family and friends this year.